All right, so we're going to practice graphing equations from tables. So this is an important technique because this is the most basic way to graph, and you've been doing it, but I'm going to make sure we run through my picky expectations. And it's really important to remember that this is always a backup plan when I start to teach you all the other good theories and properties for graphing. So we're going to start with this basic. So your job today is to graph any equation using a table and write an equation in function form, which I'm kind of doing this out of order, but function, we'll talk really specifically about what is and what is not a function. And so today we're just going to talk about what function form looks like. And then we'll talk about what function means in a different lesson. Okay, so first, a basic, tell whether this ordered pair is a solution. Well, how do I know, is this a solution? Substitute, just check your work. That's your proof. You can use your mind, but I can't read your mind, so show me your substitution. So 2 times, I'm substituting 4 minus substituting 7 equals 5, and show me what you've got. So we've got 8 minus 7 equals 5, which is 1, which does not equal 5. So, no, 4, 7 is not a solution. Or yes, it is, depending on if you get a true or false statement. Okay, so when you're graphing, your graph is a representation of an actual event or situation. So it needs to be very precise and neat. This is like, it's got to be, I'm a little bit perfectionist when it comes to graphing. So here are my expectations, and then we'll go through one. Make sure you have neat axes, straight. Use the lines on your graph paper. Neat and even intervals. So when you're putting your little dashes on your line, use your graphing paper to guide you, or if you're in line paper, just make sure they're neat and even, the exact same amount of space between them, because your intervals are your ruler. You would label intervals not equal to 1, except for in a story problem. In the story problem, always label. Label axes, X or Y, or the units. So if a story problem, you might have miles or hours instead of X and Y. You need to have a title for everything that has a story problem. And then this, since we're doing it out of order, we'll talk more about what's discrete and continuous coming up, but you need to evaluate all the word problems, and any discrete data do not connect the points, and anytime you have continuous data, connect the points, and we're going to talk about that when I get back. Okay, so just practice graphing. In a basic problem, make sure you pick both positive and negative values, because you want to show there's no context, so I don't know what it is. In a word problem, you need to pick values appropriate for the domain or appropriate for the story. So to graph this, the first thing I need in order to make a graph, I need to have points, but I don't have any points. So to have points, I'm going to make my table. Since I don't have any labels, I'm just going to label this X and Y. And we're going to pick positive and negative values. Just pick your X values and find your Y values. Okay, so pick, -3, -2, 1, maybe go to 0 and then do 2 and 3. And you only need 2 points to make a line. However, 2 points do not determine a correct line. So if you have 5 points, you'll be able to see what your graph really looks like. So I want you to pick 5 or more points. And then do your substitutions for each point. And it's best if you show all your work for this, because this is one of those things, you start to get repetitive, you start making mistakes. If you show your work, we can find those mistakes. But if you don't, we do it all again. So you either do it once with a lot of work or several times, one of the two. So I'm just going to label my work, and I'm saving room over here on my screen for my graph in a little bit here. So I'm going to substitute x equals -3 right here, and I'm going to do this really as fast as I possibly can. So y equals 2 times -3 plus, or minus 1, excuse me. I'm going to go too fast. And so y will equal -6 minus 1, so y is equal to -7. Then I substitute again, x equals 2, and so on. And I'm going to pause the video and just quick do the work so that you don't have to watch all of it, because I know you know how to substitute, so hold on. Okay, so now the work is complete and we're ready to graph. So make sure you make your axes and follow your grid paper. So this is the y-axis and the x-axis. So I have those labeled. I need to determine my intervals. So I'm kind of looking, I went from -3 to 3, so I'll probably go with 1s on my x. Let's see, on my y's, do I have enough to do -7? So 1, 2, 3, 4, 5, 6, 7. I do. And enough to do 5. 1, 2, 3, 4, 5. So I'm just going to put my intervals in so they're easier to see. And then I can go ahead and graph my coordinates, which are -3, 7, -7. And I'm going to continue graphing them. Alright, so I've got all my points plotted, and there's no context for this, so I certainly need to connect my points here so for one, you can see the shape of the graph, and two, there are many, many, many more answers. That's just some of them. And if this was a story problem, you'd have labels and a title and so on. Okay, well, we run across two different functions. We have something called a constant function and a vertical, and we've got horizontal lines and vertical lines. So they're a little harder to recognize because they look just like your substitution problem, but they have the word graph by it. Graph y equals -3. Well, we're not making a number line, we're making an xy axis. So, make your xy axis, and we'll talk about what it looks like. Oh, and I have a table to make too. So, y, x, okay. So, for my table, what a constant function means is exactly what it sounds like, constant. It's constantly -3. So everything in the y column is -3, always and forever. Pick whatever you want for x, but y is going to be -3. So I can pick -2, I can pick 1, I can -1, I can pick 2, and then I can pick 3. Okay, so all of them are -3, and you can go ahead and plot those points, and you will get a horizontal line every time at -3. But you can plot them to help you kind of get used to it. So 2, -3, I'm sorry, -2, -3. I'm sorry, you'll get horizontal, yes. So I lost my train of thought here. -1, -3, 2, -3, 3, -3. And then you'll see your horizontal line. Okay, because it's going through y is -3. Always is and always and forever. And similarly, vertical lines are similar. So, except for it's x equals 6, so now all the x things are going to be 6. So 6, 6, 6, 6. And then you can pick whatever y's you want. -2, -1, 0, 1, 2. Make your graph. Why did I pick 6? Jeez, it's a big number. Alright, so that's y and that's x, and 1, 2, 3, 4, 5, 6. 2, 3, 4, 5, 6. Alright, so now I can go ahead and plot my points. So x is 6 and y is -2. X is 6 and y is -1. X is 6 and y is 0. It's getting kind of repetitive. X is 6 and y is 1. X is 6 and y is 2. So you can see your vertical line goes through the x. So if you see x equals, it's going through the x, that's x. If you see y equals, it's going through the y. That's how you kind of keep track of which is which. And you can always make a table start with. And we'll go over this again in a couple chapters. So now we have to talk about function form. So function form is always having y equals and then everything else. Okay, so solving for y. We'll start with that. So now we can go ahead and solve for y. So I need to get y by itself. So I'm kind of going to treat kind of the x just as like a number. I need to move this number, 4x, over. So I'm moving that number over. And I have 3y left. Over here, these are not like terms, so I'm just going to go ahead and write 12 minus 4x. And now I need to divide 3. However, I need to divide the whole side by 3. So that would mean both parts, or as many parts as there are. So this will cancel to 1. And over here it's 12 divided by 3, which is 4. And this is minus 4/3 x. So make that into a fraction coefficient. Okay? This is like distributive property. We're distributing actually a 1/3. But we're just showing it in the division form. Now you have it in function form. And then we will turn into function notation, which we haven't learned yet, but normally we learn that first. Function notation is giving it a name, like f of, I take it back, we're not going to go into function notation until I get back. So right now just solve for y, and that'll set you up to do function notation once we have learned it. So again, solving this one for y. So I'm treating the x just as a number, the whole thing, the whole term. So I'm subtracting x from both sides just like I would any other number. I have 2y left, and these are not like, so don't put them together. Just rewrite it. If I divide one thing by 2, I divide everything by 2. And I've got y equals 3, and this is 1/2. There's really a 1 here. So minus 1/2 x. Alright, so you're going to get a worksheet of different things to graph. So you'll be using your graph paper to finish the examples.